Hi guys, today we have lesson 3 in unit 8, which talk about solving quadratics by the quadratic formula. So this is what we learned so far in this unit. We learned how to solve the quadratic formula using graphing, using factoring, and the zero product property. And today we're going to talk about the quadratic formula. What is the quadratic formula? The quadratic formula basically is an equation that says x equal, or the zero equal, or the solution equal, or the roots are equal to negative b plus or minus square root of b squared minus 4ac over 2a. And if you ask yourself what a, b, and c are, a, b, c are real numbers in the quadratic standard form, which is a x squared plus bx plus c. So let's take a look at our first example. We have x squared plus 5x plus 6 equals 0. Now, in this equation, we have the values of a, b, and c. A is equal to 1 because it's the coefficient next to x squared. B is 5 because it's the coefficient next to x. And c is 6 because it's the constant in the quadratic equation, which is equal to 0. Now, to use the quadratic formula, I know that the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. That means all I need to do now is to substitute the values of a, b, and c with the real numbers that I have from the quadratic formula. So I'm going to end up with x equals negative 5 plus or minus square root of 5 squared minus 4 times 1 times 6 over 2 times 1. Now, you don't even have to do the calculations under the square root. All you need to do is to put all these numbers under the square root in the calculator and find the value. So, if we put 5 squared minus 4 times 1 times 6 in the calculator, we're going to end up with negative 5 plus or minus square root of 1 over 2 times 1 is just 2. So here I have two answers. First answer is when the x is equal to negative 5 plus square root of 1, which is 1, over 2. And the second answer, or the second root, is x equals negative 5 minus 1 over 2. And if we try to find the final answer, negative 5 plus 1 over 2 is negative 2. And negative 5 minus 1 over 2 is negative 3. So the solutions are x equals negative 2 and x equals negative 3. So to check if my answers are correct or not, I'm going to put the quadratic equation in the calculator and check the answers that I got for the zeros. So I'm going to have x squared plus 5x plus 6. And I need to look at the graph. On the graph, I see that the zeros are -3 and -2. And if I look at the table, I see that the zeros are if I go up, I see that the zeros are -3 and -2. They both have a y value of 0. So these are the zeros, -3 and -2. Which means that the work that I did using the quadratic formula is correct. Okay, let's take a look at this example now. We have x squared minus 4x minus 41. A is equal to 1. B is equal to -4. And C is equal to -41. And we know that the quadratic formula is x equals -b plus or minus radical b squared minus 4ac over 2a. So what I need to do now is to switch the values of a, b, and c with the real numbers that I have in this quadratic. So I'm going to end up with -4, which is 4 plus or minus radical. I'm going to put -4 in parentheses before I square that number. And remember, this is what you have to do when you put the numbers in the calculator, or the calculator is going to give you the wrong answer. Times 1 times -41 over 2 times 1. Now, all you need to do at this point is to put all the numbers under the radical in the calculator to find the value of all these numbers. And you're going to end up with 4 plus or minus radical 180 over 2. And I can simplify this radical even more. 180 is basically 36 times 5, so I'm going to have radical 36 times radical 5 over 2, which means I'm going to end up with x equals 4 plus or minus radical 36 is 6 times radical 5 over 2. I also can simplify this even more by breaking down the fraction into 2 parts, where I have 4 over 2 plus or minus 6 radical 5 over 2. Looking at the first part, I'm going to have 4 divided by 2, which is 2, plus or minus 6 divided by 2 is 3, and I have 3 radical 5. And that's the answer. Now, to check if our answers are correct, using the quadratic formula, first we have to find out what 2 plus 3 radical 5 is equal to using the calculator. And the first value is equal to 8.701, which I'm gonna round to 8.71. And the second value, which is 2 minus 3 radical 5, is equal to negative 4.708, which I'm going to round to negative 4.71. So now when I graph my parabola, I should expect the parabola to intersect the x-axis at two places, or at two x values, 8.71 and negative 4.71. So let's see if that's what's going to happen. So in y equals, I'm going to put my equation, which is x squared minus 4x minus 41. And in y2, I'm going to put 0 to find the x-intercept, or where the parabola intersect the x-axis. So I'm going to hit the second button, the trace button, and I'm going to go to number 5 where it says intersect. And then I'm going to hit enter. So the calculator is going to ask me to verify the curves. So the first curve that I should have is the curve of the parabola. And in this case, all I need to do is to hit enter. And the second curve is for the red curve, which is the x-axis. So all I need to do is to hit enter again. And the calculator is going to ask me to guess. I'm not guessing. I need to, one of the values. And the first value the calculator is going to give me is negative 4.701, which we said is negative 4.71. So the first one is correct. Now all I need to do is to find the second value. So to get to the second value, I'm going to get closer to that value by asking the calculator to move the pointer to one of the closer x values. So I'm going to do the second button, the trace button, and I'm going to go to value, which is number 1, and I'm going to ask the calculator to go to a closer x value, and I'm going to choose 1, 2, 3, 4, 5, 6. I'm going to choose 7, and then hit enter. So now my pointer is supposed to be closer to the other 0, or the other value that I need. For that reason, I'm going to go hit the second button again, trace again, and then I'm going to go to number 5 to find the intersection point between the parabola and the x-axis. I'm going to hit enter for the first curve, hit enter for the second curve, and then hit enter again because I don't want to guess. And the answer that the calculator is going to give me is 8.708, which we said is going to be 8.71. So the values that I got using the quadratic formula are indeed correct, and my work is verified graphically.